and it has identical mass. And it has identical mass with proton. It has what? Identical mass with what? Proton. Comma. This make it to change to what? Proton. This make it to change to what? Proton. This make it to change to what? Proton. Full stop. Now, hello. Sometimes your neutron can act as what? As a proton, and your proton can act as what? A neutron. Why did they interchange? It's because they both have the same word, masses, and not just that, they are both found in the what? In the nucleus of what? Of an atom. Are you getting me? The only difference between your proton and your neutron is the value for what? Charge. Are you getting me? Because your proton is neutral, it has no what? Charge. Sorry, your proton has what? A positive what? Charge. While your neutron has no what? Your neutron has no what? Charge. Alright. And it is found in the nucleus of an atom. And it is found in the nucleus of what? An atom. And it is found in the nucleus of an atom. And it is found in the nucleus of an atom. Full stop. So the next one is electron. 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 Shall we? This is a negatively charged particle. This is what? The negatively what? Charged what? Particle. With a value of minus 1.602 times 10 power minus 19 colon. Minus 1.602 times 10 power minus 19 what? Colon. Have you written that? Minus 1.602 times 10 power minus 19 what? Colon. You can see that your neutron is negative. But it's the same value with that of your what? Your proton. Is it not? The same value of charge now, right? The only difference is that your proton is what? Positive, while your neutron is what? Negative. Your electron is what? Negative. And it has a mass value of and it has a mass value of 9.11 times 10 raised power minus 31 kilogram. It has a mass value of what? 9.11 times 10 raised power minus 31 what? Kilogram. And it is found outside the nucleus of an atom. It is found outside the nucleus of what? An atom. It is found outside the nucleus of an atom. It is found outside the nucleus of an atom. Have you written that? It is found outside the nucleus of what? Of an atom, full stop. So this now takes us to electronics. Electronics. You can see the word electron. Hello. So electronic was extracted from the word what? Electron. Are you following? Alright, please say that. Electronics. 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 This is a branch of engineering. This is a branch of engineering. Electronics. This is a branch of what? Engineering, which deals with current conduction. We deal with current conduction. We deal with current conduction. We deal with current what? Conduction through a vacuum. Through a vacuum, comma. Through a vacuum, comma. Gas and semiconductor materials. Through a vacuum, gas and what? Semiconductor what? Material. Through a vacuum, comma, gas and semiconductor what? Material. That's an electronic device. Electronic device. Electronic device. Electronic device. This is a device. This is a device. This is a device in which current. This is a device in which current. In which current flows through a vacuum. Flows through a vacuum, comma, gas and semiconductor material. Gas and semiconductor what? Material. Gas and semiconductor material. Alright, full stop. So we have functions of electronics, electronic device. Functions of electronic device. Functions of what? Electronic device. Your normal household appliances, they are all what? Electronic what? Devices. Even your cell phone is also what? Electronic what? Devices. So all those electronic devices, they have their own what? Functions. Are you following? Alright, number one function is rectification. Rectification. Number two, amplification. Then number three, we have control. Number four, we have generation. Number five, we have conversion. Conversion of light to what? Electricity. And then we have conversion of electricity. Conversion of electricity. Electricity to what? Light. So these are the functions performed by what? Electronic what? Devices. Okay, when you are converting your AC signal to what? DC signal, that is your rectification. Okay, we also have applications, especially those that normally work with the median, the TC unit in the church. Okay, you have seen an amplifier before now, right? To amplify sound, is it not? Alright, so we also have control, we have generation. So we have conversion of light to what? Electricity, and conversion of what? Electricity to what? To light. So again, you can ask the functions of electronic devices. So these are the functions of what? Electronic devices. So under Boyle's atomic model, so there are some proving that we're about to do now. Okay, and we have two ways. Now you have to test for the course. So the way they prove it in this other textbook is quite different from the way they prove it in the other word textbook. Okay, all right. So I can write this right. for class now? Which class will go viral? Twitter, energy. So we are going to prove them. Even if at all, we are going to say anyone in your exam should really feel velocity. Okay? But see, they didn't teach you guys like that. Are you getting me? And they did almost all this proving. They might even give you more of the words, more of the proving. Please don't noise. Alright. So prove velocity. Going back to our main case. From your main case, we are told that your angular velocity, that's W, is equal to V over R. You can remember that. We call this equation. Then the next one is your moment of inertia, I, equals to mr squared. So we call this equation 2. Please no noise. You also have moment of electron around its orbit. Is IW equals to NH over 2pi. Call this equation what? Stating as angular momentum. Now this time around, what you will do, you substitute equation 1 and equation 2 into equation 3. So it's stating as put equation 1 and 2 into what? Equation 3. Our equation 3 is IW equal to NH over 2pi. Now our I, which is moment of inertia, is taken as what? mr squared. Then it times what was W? V over R. Then equals to NH over 2pi. So from here, mr squared times V will give us what? Vmr squared, right? So over what? R equals to NH over 2pi. Am I too fast? From here, these can cancel out this. How many R will be left there? Will be left with one word, R. So from there, it becomes Vmr equals to NH over 2pi. What we are looking for is what? V. To get our V, what do you do? What? Cross multiply. And if you cross multiply, we have V, then mr 2pi, then equals to NH. Now to get our V, you divide everything by everything here, right? So our V becomes NH over mr 2pi, is it not? So if you rearrange your denominator, it's going to be V equals to NH over 2pi mr. Equation what? 4. So that is the proving for what? Velocity. Now that you've gotten that, so the next one is our radius. Now, alright, you can copy that. All this proving is under Boy's atomic model. Now, to prove for radius, you recall from your electricity and magnetism, other electrostatics, we are told that F equals to, please don't noise, that is electrostatic force, is equals to K Q1 Q2 over R squared, right? But this time around, in place of your Q, you replace it with what? With E, which is what? Electron. Electron is in charge, is it not? So instead of writing E1, E2, you can replace it with K, that is E1 and what? E2. In place of what? U1 and what? E2 over what? R squared. Now, under electrostatic, I told you then that your K is equal to 1 over 4 pi SLN naught. Is it not? So in place of your K now, I can decide to replace it with this. So it's taken as Fe equals to Ke square, right? Then over R square. That is from there, it becomes, what's our K? 1 over 4 pi SLN naught. Then times what? E square R square. Is it not? Now from there, this is taken as what? E square. Then over what? 4 pi SLN naught R square. Now this time you add Z to it. Okay, that Z there is constant. Now from here, simply that your Fe, hello, pay attention, is Z square over 4 pi SLN naught R square. So I just explain how this one came about. Okay, but when you are doing your normal program, you not necessarily must pass through all these words, all this stress. Are you getting me? So as long as you can remember this formula, you can go out ahead with your process. Is that clear? Now, and not only that, the under centripetal force, Fc, I tell that the centripetal force is equal to mv squared. Then over arrow, is it not? Centripetal force is equal to what? mv squared over arrow. This is your electrostatic force. Why is the word centripetal force? And force is measured in what? In Newton. So from there, your Fc can be equal to what? Fe, because they are both measured in what? In Newton. Are you following? So what's our Fc? Is mv squared then over arrow squared. Is it not? Yes. So mv squared over arrow, sorry, not arrow squared. So is mv squared over arrow then equals to what's Fe? Arrow square, right? What are we looking for? We are looking for what? Radius, right? Then before that, what do you do? To cross multiply. Are you following? Yes. And if you cross multiply, we are going to have 4 pi SLN naught arrow square then mv squared. Is it not? Then equals to Z squared arrow. So from there, this can cancel out this, right? So how many arrows will be left here? 1. So this is taking as, let's say, 4 pi SLN arrow mv squared equals to what? Normally we are looking for arrow now, right? You divide everything by whatsoever you have here, is it not? So from there, our arrow will be equals to Z squared over 4 pi SLN naught mv squared, isn't it? Yes. Now, if you compare these two equations and this, are they the same? No. Are they the same? No. They are not the same. What you do, you can decide to call this one equation what? 5. No. You can call this equation what? 5. Then, remember there, we said let it be our equation 4, right? Yes. So now substitute your equation 4 into what? Equation 5. So we put equation 4 into what? Into 5. So from there, our arrow will be equals to Z squared over, then we have 4 pi SLN naught and what's our V? N over 2 pi M arrow, is it not? Yes. So our V becomes N over 2 pi M arrow, then all square. So our arrow there will be equals to Z squared over, there become 4 pi SLN naught and every year is raising to power 2, right? Yeah. N raised to power 2 is what? N squared. H raised to power 2 is what? H squared. Then all over 2 raised to power 2, 4. Pi raised to power 2, 9 squared. Then N raised to power 2, N squared. Arrow squared. Is it not? Yes. Now this one is taking as arrow equals to Z squared divided by 4 pi SLN naught N squared H squared over 4 pi squared M squared arrow squared. Now, if I'm checking this division equation to times. The denominator will move toward numerator, and numerator will move toward denominator. And then we have it as arrow equals to
Z squared times 4 pi squared n squared arrow squared over 4 pi epsilon naught n squared a squared.
Now from there, 4 can cancel out 4, right?
Yes.
5 cancel out 4. How many pi will be there?
1.
N cancel out N. How many pi will be there? Alright, this can cancel out this, right?
Yes.
What we left in this side? 1. So at the end of it, you are going to have it as 1 equals to Z squared. Then we are left with pi. Then N arrow all over what? What's left here? N squared. We have E naught N squared. What will you do there? So we have Z squared pi N arrow equals to E naught N squared A squared. To get arrow, we have to start like this, right?
Yes.
So our arrow equals to E naught N squared A squared over Z squared pi N Now let's check, please don't know if we are correct. As long as all the ingredients are there, we are correct.
Yes.
Now from the numerator, we have E naught, right?
Yes.
We have N squared, N squared. We have N squared, A squared. Then we have Z, we have Z. We have E squared, we have E squared. We have M and we have M, right? And we have what? Pi. We have pi. So you can decide to call to an equation. Hello. So you can copy that. Let's energy. So electrostatic force and centripetal force. Remember I told you that your Fe is equals to Z squared over 4 pi epsilon naught r squared. Is it not? Then y Fc is equal to what? F squared over r. And I told you that your Fc is equal to Fe. What's Fc?
mv squared over r.
Mv squared over r. Then equals to Z squared over 4 pi epsilon naught r squared. So from here, we want to make mv squared the subject of the word formula. What do you do? Cross multiply. Okay, this is taking as mv squared 4 pi epsilon naught r squared equals to z squared, right? Or better still, please no noise. This can cancel out this, right? You'll be left with what? mv squared equals to z squared over 4 pi epsilon naught r. So you can call this equation what? 7. Now, you recall that your linear kinetic energy. Linear kinetic energy, that's Ke, is equal to half mv squared. Is it not? They call this equation what? 8. So substitute equation 7 into equation 8. So from there, put equation 7 into 8. So from there, Ke will be equal to half. What's mv squared? Mv squared is as everything there, right? Z times Z squared over 4 pi epsilon naught r. So this time around, if you do this to multiply this, we have that J equal to 1 times Z squared. Z squared over 2 times cos squared. If you compare these two equations, are they the same? No. What you do, you can see that you still have your radius there, right?
Yes.
But in this equation, you get like radius. No. So you can call this equation what? 9. So what you do, you substitute the equation for radius, which is equation 6.
Yes.
So you put equation 6, into 9. So now our equation 9 is KE equals to Z squared over 8 and epsilon R. So from there, KE is equal to Z squared over 8 pi epsilon. What's R? R is E naught, Z squared over Z squared by N. Is it not? Yes. Alright, this is as KE equal to Z squared over this is as 8 pi E naught times E naught squared, right? N squared over Z squared by N. So this is as KE equals to Z squared divided by 8 pi E naught squared N squared over Z squared by N. If I'm changing this to time, this one will move to numerator, this will move to denominator. So our KE will be equal to Z squared times Z squared by N over 8 pi epsilon squared N squared. So from there, I can write this right. Alright, we have KE equal Z times Z give us what? Z squared. Then E squared times E squared. E4. Then pi what? N. Then all over this is now what? 8 by E naught squared N squared A squared. Pi can cancel out pi, isn't it? So what we left the KE equals to Z squared E4 N over 8 epsilon squared N squared A squared. Equation 10. Now let's check. Do we have M there?
Yes.
Do we have Z squared?
Yes.
Do we have E4?
Yes.
We have 8, right?
Yes.
Epsilon squared,
Yes.
then N squared,
Yes.
then H squared. So that is the worst equation. Alright. So we are going to stop at this.